Okay, let's go ahead and give this a shot. I thought this would be best if I had my picture right there in the corner so you could follow my facial expressions as I did this the whole time. All right, so number 79 from your homework, it's similar to the test. We're going to go ahead and find everything that's left at the end so we can become very good at this. Watch this, watch the class video from today, do your homework. Hopefully you'll feel okay. So these are the two masses that are given. If that's wrong, I didn't look in your book. I'm looking from an other year. So it could be a little different, but whatever. This is a great practice problem. So I've already written, I've already balanced. So the next thing to do is to determine your limiting reactant. All right, so I'm going to put 2 picket fences. And remember the picket fences, I start them with each of the 2 givens, but I solve them both for the same product. So I'll just go with NaNO3 here, grams NaNO3, and grams of NaNO3. All right, then I'll come up here. I'm given 3.50 grams Na2CO3. Oh shoot, I had this on the previous screen. Let me get the masses real fast, save some time here. Okay, so what I did, I went and found these masses. If I made any mistakes on them, I apologize, but I think that they're pretty solid. So we're going to use these to complete our picket fences. All right, so in this top one, I have Na2CO3, so I find that 105.99 grams Na2CO3 for every 1 mole Na2CO3. Now, helping some kids, I've noticed that they've gotten a little bit lazy and they're not writing the whole unit. If you don't include what species you're talking about, you may get confused on what species to put down below. All right, so I have to match that. I look for the coefficient. I have 1 mole Na2CO3. All right, then I'm going to NaNO3. So I'm going to come over here, and I have a 2 mole NaNO3 right here. All right, that's from this coefficient. Then for every 1 mole NaNO3, I have 84.50 grams. Now my units match, so I'm ready on that one. Now let's go here. I have 5.00. I'm going to be lazy and just put 5 grams of AgNO3. The molar mass of that is 169.88 grams AgNO3. Grams are always per 1 mole of the same thing, AgNO3. Down here I must need mole AgNO3. Then I'm running out of space here. There is a 2 in front of that. So put a 2 here, and then the top matches the one above. I have 2 mole NaNO3. I have 1 mole NaNO3. On top, I have 84.50 grams NaNO3. Then let me pause this and do some math. All right, so I did these 2 picket fences. I did this math. I checked it twice, so hopefully I didn't screw up, but I still may have. Pray for me. Sometimes I just do stupid things. All right, now the bottom one is definitely a smaller value, so I'm going to cross these out. That was a poor color choice. I thought that was this one. All right, so I'm not going to use this data at all because this would be my excess. All of the data I need is going to be determined by my amount of my limiting reactant. Okay, so right off the bat now I'm ready to do a couple of things. My limiting reactant is AgNO3. So I'm going to put it in blue. The mass that remains of this at the end is 0 grams because the mass of the limiting reactant is always 0. All right, I also solved for the amount of NaNO3, so that I already know is 2.49 grams. So the next step is to solve for this, and the one after that will be to solve for my excess. Okay, so now that I know what my limiting is, I just set up another picket fence, and I have at it. Now, I did this in class, and I'm going to do it again. This part of the picket fence is the same from now on. So I'm going to go ahead and find that answer. I have 5 and then 169.88. I divide that and I get 0.0294 as my mathematical value for that piece. Now the unit of that is what's here, moles, AgNO3. So I'm going to use that in all my picket fences from now on. So let's do this. What I'm solving for now are my grams of my other product, Ag2CO3. All right, and I'm going to start. I screwed that up, didn't I? Get this out of the way. Okay, so I'll start my picket fence with that value from here, 0.0294 moles AgNO3, and this goes down also. I have 2 moles AgNO3 for every 1. If you look up here, there's a 1. So I have 1 mole Ag2CO3. Then for every 1 mole Ag2CO3, I come up here and I find the mass. Ag2CO3 is 275.74 grams. All right, and then I will do that math. Hold on. All right, when I did that math, I got 4.06 grams of Ag2CO3. So that's the amount of mass of my other product. So my last step to do is to find the mass of excess. So once again, it's another picket fence. I start with the same thing. Let me go ahead and set this up. Now, these are shorter picket fences because remember, I've already put this part in. Oops. And solved, so I don't need that extra step unless you did it the longer way. It's not harder. But if you had 5 in there still, it's fine. 0.0294 mole AgNO3. Now, remember, we are finding the grams used. Please remember, write used. That way you won't write at the end. This is the grams used up. And that's going to be of Na2CO3. So I still have 2, so same every time. Then in front of Na2, there's a 1 right here. So there's a 1 on top. For every 1 mole Na2CO3, I found that mass, and it was 105.99. Okay, do some math. Okay, so let's wrap this up. When I did the math, I found that it was 1.56 grams of Na2CO3 used if I have that amount of my limiting reactant. So the final step here, you take that number you just found that you used up, you subtract it from the initial mass given, and I got that number way up here. It gave me 3.50 to start. Uh-oh, come down. So I have that minus 1.56, which I just found in my used, and I was able to calculate 1.94 grams of excess. So I'll go ahead and put this up here. We went blue with that. So this is ugly, but 1.94. Sorry, I didn't write the right answer. Yeah, I did. Okay, so that's my mass there. I neglected to write the 4.06. That's why I was confused. Right here. So these are my 4 answers. I know this is hideous. Oh my heavens, sorry. So my mass of Na2CO3 is equal to 1.94. AgNO3 is equal to 0. NaNO3 is equal to 2.49. And my Ag2CO3 is equal to 4.06. All right, to check that we're right, we add these up. I already did that on my calculator, and I got 8.49. This, what I started with, was 8.50. So this is very close to this, so we are correct. All right, I hope that this and the other resources has helped you, that you can prepare for your test. Good luck. It's just like these and the one we did. Anyway, good luck. See you tomorrow.